Download this code and get free GPT-4o from codegive.com, link in the description below. Microsoft Visual Studio's MSVC, Microsoft C/C++ compiler, has made significant strides in improving the performance of debug builds over the years. Debug builds are typically used during development because they include additional debugging information and do not optimize the code as aggressively as release builds. However, with enhancements in the MSVC toolchain, developers can enjoy improved performance even while debugging. Key improvements in MSVC for debug build performance. 1. Optimized debug information. MSVC now generates more efficient debug information, allowing the debugger to consume less memory and process data faster. 2. Just-in-time, JIT, compilation. MSVC's JIT compilation allows the debugger to compile code on the fly, which can help in scenarios where the execution path is not frequently taken. 3. Enhanced debugger performance. The Visual Studio debugger itself has been optimized for better performance, especially with features like Edit and Continue, which allows developers to modify code while debugging without restarting the session. 4. Native code optimization. Although debug builds traditionally focus on debugging, MSVC allows limited optimizations even in debug mode, example /ODVS/01/02. This means you can still benefit from some performance improvements while maintaining the ability to debug effectively. 5. Profile Guided Optimization, PGO. MSVC supports PGO, which helps in optimizing the most frequently executed paths even during debugging. Example scenario, improving debug build performance. Let's illustrate how to set up a simple project and leverage some of these MSVC features to improve debug build performance. Step 1, create a new project. 1. Open Microsoft Visual Studio. 2. Create a new C++ console application. Step 2, write a sample code. Here's a simple code snippet that simulates a performance-intensive task. CPP. Include IOStream. Include vector. Include chrono. Void perform heavy computation, int n. std vector int data, n, 0. 4, int I equals 0, in, plus I. Data I equals I asterisk I. std code computation done for n elements. std end l. Int main. Auto start equals std chrono high underscore resolution underscore clock now. Perform heavy computation, 100 million, / simulating heavy computation. Auto end equals std chrono high underscore resolution underscore clock now. std code elapsed time. std chrono duration underscore cast std chrono milliseconds, and, start, dot count. std end l. Return 0. Step 3, configure project settings. 1. Set configuration to debug. Go to Build-Configuration Manager and ensure the active solution configuration is set to debug. 2. Enable limited optimizations. Right-click on the project in Solution Explorer and select Properties. Navigate to C/C++-optimization. Change the optimization setting from disabled, /OD, to full optimization, /O2, for debugging purposes if you want to experiment with limited optimization. 3. Enable Edit and Continue. Under Debugging, ensure that Enable Just My Code is checked and Edit and Continue is enabled. Step 4, run debugging session. 1. Set a breakpoint at the beginning of the perform heavy computation function. 2. Start debugging, F5. 3. When the breakpoint hits, use the watch window or immediate window to inspect variables. 4. You can modify the code while debugging, if edit and continue is enabled, and continue execution without restarting the session. Hashtag Step 5, profile your application. 1. Use the built-in performance profiler in Visual Studio to analyze the runtime performance of your application. You can do this by going to Debug-Performance Profiler. 2. Select CPU usage and start the profiler to gather performance data while your debug build runs. Hashtag Summary. With continuous improvements in MSVC, developers can achieve better performance even in debug builds. Utilizing features like optimized debug information, limited optimizations, and advanced debugging tools can significantly improve the development experience. By following the steps above, you can leverage these enhancements to make your debug builds more efficient.